Hey guys, welcome to another installment of the beginnings of college algebra. This is some more foundational material. Today we're going to talk about two different topics. Well, it's the same topic. So we're in chapter P of your textbook, and this is factoring polynomials. So we're going to break this. I'm going to do two videos on factoring. I'm going to do factoring everything but the trinomial deal, and then I'm going to do the trinomials separately. All right, so you'll have two videos for factoring because this typically is a place where students struggle, and even though you've seen a lot of this before, many of you guys need to see it again. So that's okay, that's what I'm here for. All right, so there's a lot of things we're going to do in this particular video. All right, in this particular one we are going to do factoring out the greatest common factor, factoring by grouping, difference of squares, and sum or difference of cubes. So those are the four things that we're going to do in this particular video. The second video will cover the other stuff, so you don't have such a long video. So these are kind of the more basic ones, the things that if you remember something from your previous algebra skill classes and stuff, this is probably the stuff that you remember. But let's go through it anyway. All right, so when we're factoring simply means that we are trying to rewrite an equivalent expression as a product. All right, so factoring is really dividing out or undoing a multiplication process, either a distributive process or a FOIL process. All right, so opposite of multiplication is dividing. And so that's what we're doing, is we're attempting to factor. And if you remember with numbers, right, if you factor your numbers down, 8 goes down to 4 times 2, and then 4 is 2 times 2. And so this is what's known as the prime factorization. Same idea. We're looking for the building blocks of a polynomial that when you multiply them together, you get your polynomial. And so we're trying to undo the stuff we did in the last section. The greatest common factor is the simplest of the factoring concepts, and that is when you have a term that is equally divisible, okay, equally divisible in each of your polynomial terms. If you have two terms, then you can divide it out of both. If you have three terms, you can divide it out of all three. It's not a common factor if it's not in all of the terms, right? So if you have 4x cubed plus 8x squared minus 11, right? These two factors, these two guys have 4 and x squared in common, but 11 doesn't have any of that stuff. And so this has no greatest common factor at all other than 1. All right, so in order to be common, it can't just be in a couple of them. It's got to be in all of them in order to be common. Okay, so here's do an example. Let's factor this first one, 10x cubed minus 4x squared. All right, inside of 10x cubed and 4x squared, what do we have that's in common? Well, we notice we take the lowest power of x. The lowest power of x is x to the second power, because x cubed is the same as x squared times x. So x squared is inside of x cubed, right? And then 4 is 2 times 2, and 10 is 2 times 5, and so there's a 2 in common. So 2x squared is what's in common to both of these guys. So our GCF for this problem up top here is 2x squared. And now how do we factor out that 2x squared? We take 2x squared and we divide the 10x cubed by it. So if you divide 10 by 2, you get 5 left. X cubed divided by x squared, you subtract the exponents. What's left if you take the x squared away? There's only an x left. So we have a 5x left. Same thing with this one. Factor out the 2x squared. X squared divided by x squared is just a 1. And then 4 divided by 2 is just a 2. So that's what's left. And then now you recognize, hey, 2x squared is the same in both of these guys. And so now I undo the distributive property. I put the 2x squared out front, and I combine the 5x and the minus 2 in parentheses. Don't forget your parentheses, okay? So in a similar fashion here, notice that x minus 7 is actually the common factor. It's a group, but that's okay. A common group can still be a common factor. And so if we put x squared or x minus 7 out front, then when you divide x minus 7 away, you're left with a 2x. When you divide x minus 7 away, you're left with a plus 3. And you end up with x squared, or x minus 7 and 2x plus 3. Okay, this method of factoring right here, this factoring a group out, is going to be important for our next process. Okay, so make sure you do plenty of practice with greatest common factors. Those are the most basic, but they are essential to being able to understand factoring. You must be able to do the greatest common factor. So make sure you do plenty of practice problems on those. Okay. So now we're going to do factoring by grouping. Factoring by grouping usually, not always, but usually is reserved for polynomials with 4 terms. Okay, if you have 3 terms, you can break them up and make them 4 terms, but factoring by grouping doesn't work if you don't have more than one group. And so an example of what that looks like then is x cubed plus 5x squared minus 2x minus 10. All right, so what we're going to do is basically we're going to group the first 2 together and the last 2 together, but I need a plus in between. I need to keep these guys added together. Okay, so if you take a look here, all right, we've grouped the x cubed plus 5x squared, and then we put a plus in between, and we group the negative 2x and the minus 10. Right, so now what's in common here? What's in common between these first 2 terms only? What's in common between x cubed and 5x squared? The greatest common factor for the first set, right? There's an x squared and an x cubed, so the greatest common factor is x squared for this guy. What about for this one? What's in common between negative 2x and negative 10? Well, the greatest common factor here for number 2 is the 2, but I'm going to also take this sign. Whatever this sign is right here in the first term of your second group, you must take that sign out with you. So I'm going to take out the negative 2 as my greatest common factor for the second one. Okay? So I want to factor out x squared from the first group. I'm going to factor out negative 2 from the second group. All right? There's what I get. I get x squared. X squared times x is x cubed. 5x squared divided by x squared is 5. Factor out the negative 2. Negative 2x divided by negative 2 is x. Negative 10 divided by negative 2 is positive 5. Make sure you keep the sign straight. And then now what do you notice? If you do factoring by grouping correctly, x plus 5 in that group, x plus 5 in that group, now we have a greatest common factor. Okay, now we have a greatest common factor in the second group of x plus 5. So we factor out that greatest common factor of x plus 5, and we're left with x squared minus 2 inside of here. X squared from there, minus 2 from there. So that's how you, step by step, break down this cubic 4-term polynomial, x cubed plus 5x squared minus 2x minus 10, and breaks it down into this perfectly factored x plus 5 and x squared minus 2. Okay? That's factoring by grouping. You're going to need to practice that as well, and we're going to use that method when we go to factor trinomials. We'll do that in a little bit in the next video. Okay, now here's some of the special formulas. So these are special factoring formulas, and the book gives you a couple extra that I'm not going to deal with. I'm not going to deal with perfect squares because perfect squares can be done using the trinomial formula, and usually we don't recognize them as perfect squares. So the difference of 2 squares, if you have a squared minus b squared, remember that's where we had multiplied a plus b and a minus b because the negatives and the positives cancel, the middle terms cancel, the o and the I when you FOIL. All right, and please note that the sum of squares does not factor. Unless there's a common factor between the two, that is a prime binomial there. So x squared minus a squared minus b squared factors a squared plus b squared does not factor in general. There's no formula for that, okay? So when you look at something like 36x squared minus 25, what you need to be thinking here, we want to be thinking a squared minus b squared. So what's squared to give you 36x squared? Well, to be squared, if a squared is 36x squared, then a would have to be the square root of 36, which is 6, and the square root of x squared, which is x. Technically, that's not completely true, but we'll leave that for now. And then here, 25, b squared is 25. So what squared gives you 25? 5 squared is 25. Okay. So you need to, and you don't have to write it out the way that they do it here, but just to see it, right? 6x all squared minus 5 all squared. So now we're in this form, a squared minus b squared. And what's the formula for a squared minus b squared? Right, the formula is a plus b in one term and a minus b in the other term. You can switch the order, it doesn't matter. And so then you come down here and we get a 6x in the first 2 spots and a 5 in the second 2 spots, a plus in one and a minus in the other. 36x squared minus 25 factors into 6x plus 5, 6x minus 5. Okay, and that's just following a formula pretty much, but it's a pretty straightforward formula. Now, you probably don't even need to do this a, b over here like that, but the reason that I did that is because the next formula is for sum and difference of cubes, and now notice that there is one for sum of cubes and for difference. There's one for each. There's not one for sum of squares, but there is one for sum of cubes, and then of course there's one for difference of cubes. And so now you've got a and b playing this role, but you've also got a squared minus ab and plus b squared, or a squared plus ab and plus b squared. And so you've got to kind of know these are very similar patterns here. The plus goes with the first term, this term's opposite. Here the minus goes with the first term, this term's opposite. Okay, so, and it's always plus b squared. So let's take a look at an example there of 125x cubed minus 8. So again, a cubed minus b cubed, what's playing the role of a cubed? A cubed is 125x cubed. Well, if that's a cubed, then what's a have to be? The cube root of 125 is 5. Your calculator can help you with that. Cube root of x squared is just x. So a is 5x. B cubed is 8 apparently, and so that means b is the cube root of 8, which is equal to 2. So again, 5x and 2, identifying that means that now I can just plug in to all these spots. I can just write my formula down, and you're going to have to memorize this formula. I'm not going to give it to you, okay? But if you're doing a test, obviously, a quiz online or something like that, then you've got your notes in front of you and whatever. But you should try to know that formula, okay? So playing the role then of A is 5x, playing the role of B is 2, and so you end up, if you use the formula, with 5x minus 2 times 5x all squared, not 5x squared, but 5x all squared, 5x times 2, 2 squared. Okay, so here's a, b, a squared, a times b, and b squared. Okay, and then from there, you multiply out 5x and get 25x squared. 5x times 2 is 10x, 2 squared is 4. And then almost every single time, pretty much every time, that will not be factorable. When you do a difference of cubes or a sum of cubes, your trinomial will be a prime trinomial, not factorable. Because remember, if your instructions say factor completely, you've got to factor it all the way down as much as you can do. Okay, not factorable. Okay, so get in there and do some practice, guys. There'll be another video on section 5 that focuses specifically on factoring trinomials, both with a 1 in the front of the x squared and with other numbers in front of the x squared, and that will be a separate video that will be ready momentarily. So we'll see you later.